following program is rated G. It is suitable for all audiences.
You're watching AHA Believe! I'm your host, Janine, together with Dawen and Sarah. Experience teaches that you can make things move by either pushing or pulling them. This video discusses how affects motion. In this video, we will state the 3 laws of motion, discuss the concept of inertia, and cite applications of the 3 laws of motion. And before we proceed to the 3 laws of motion, I will give you some brief history of Sir Isaac Newton.
This is the brief history of Sir Isaac Newton. Sir Isaac Newton was one of the greatest scientists and mathematicians that ever lived. He was born in England on December 25, 1643. He was born the same year that Galileo died. He was lived for 85 years. Isaac Newton was raised by his grandmother. He attended Free Grammar School and then went on to Trinity College, Cambridge. Newton worked his way through college. While at college, he became interested in math, physics, and astronomy. Newton received both a bachelor's and master's degree. While Newton was in college, he was writing his ideas in a journal. Newton had new ideas about motion, which he called these 3 laws of motion. He also had ideas about gravity, the diffraction of light, and forces. Newton's ideas were so good that kids ignited him in 1705. His accomplishments laid the foundation for modern science and revolutionized the world. Sir Isaac Newton died in 1727. In this lesson, you will develop an understanding of each of Newton's 3 laws of motion.
Newton's first law of motion is the law of inertia. This law states that
an object at rest tends to remain at rest. If in motion, it will tend to move at constant speed in a straight line, unless it is acted upon by an unbalanced external force.
what is an external force? As the name implies, it is a force which is external to the object. To get a tricycle to move forward, you have to exert an external force on the tricycle. You push from the outside. A push from inside the tricycle would be an internal force which can never move the tricycle forward no matter how hard you push. Forces are always acting on everyday objects, but if these forces are balanced, there will be no change in the object's motion. A book lying on a table is being pulled down by gravity and pushed up by the table. These forces are balanced so the book will remain at rest, unless some other external force acts on it. Here are some pictures that will show you the law of inertia.
You can see that the ball is in motion. Any unexerted and unbalanced force, the ball stops. A piece of paper and a 5 peso coin are set up on the top of a glass of water, is shown in this video. What will happen to the coin if we unfold the paper? You can see the 5 peso coin drop into the glass.
Now that you understand Newton's first law of motion, let's go on his second law. This is the law of acceleration. According to Newton's second law,
An object's acceleration is directly proportional to the net force acting on it, and is inversely proportional to the object mass. The object always accelerates in the direction of the net force. The second law of motion can be expressed as a mathematical equation. Here is problem number 1. Using what we know, let's say that on the way to work, May-Ann's vehicle break down. Her car weighed 100 kilograms. As she pushing her truck, she able to make it roll at 0.05 meter per second square. Since she know second law of motion, she can calculate how much force she pushing on her car. First, we need to write the given value. The mass is equal to 1,000 kilograms. The acceleration is equal to 0.05 meter per second square. The formula that we use is the force equals mass times acceleration. We substitute the given value to the formula. 1,000 kilograms times 0.05 meter per second square. The answer is 50 newtons. So May-Ann needs 50 newtons to push on her truck to make it move.
here are some videos that will show you the law of acceleration. If you push a broom with hand, it accelerates. If you push twice as hard, the broom accelerates twice as much. Push 3 times as hard, and the broom accelerates 3 times as much. As does not change, the force is directly proportional to the acceleration. Increasing the force, increasing the acceleration. Decreasing the force, decreasing the acceleration. Every experience tells us that a heavier object is harder to move than a lighter one. Pushing one loop is easy. Exerting the same force on the two loops gives only half the acceleration. Giving the same force on the 3 loops would give only 1/3 of the original acceleration. Pushing with the same force, we find that increasing the mass decreases the acceleration. We can say that pushing with the same force, we can find that increasing the mass decreases the acceleration. We can say that the acceleration is inversely proportional to the mass. This is easy. Let's go on to the next law. This law is the third law of motion. This is the law of interaction. According to this law,
For every action, there is an equal and opposite reaction.
here are some videos that will show you the law of interaction.
A newly waxed floor. Thoughts are common as walking involve action and reaction forces. You push the ground, it is the action force. The ground pushes you forward, it is the reaction force. Without the ground's reaction force, walking would be difficult, if not impossible. You would quickly realize this if you try walking on slippery ice or on
We could have had it all. All rolling in the deep. There's a fire starting in my heart, reaching a fever pitch, and it's bringing me out the dark. Finally, I can see you crystal